This video is over graphing system of equations test review. When graphing a system of equation, we're going to start with one equation at a time. In our first equation, y equals x plus 3. Remember, we know that this is really a 1x. Anytime there's no number, it's an understood 1. We're going to start by pulling out our mx value. Mx is the 1. And the plus b value at the end, 3. Remember, those values come from our general equation of y equals mx plus b. Once you pull out those values, you can go ahead and graph them. Graph the b value first. So starting at 0, we're going to graph the 3, 1, 2, 3, and we put a point. Now when we graph the positive 1, positive is up. So we're going to go up 1 and then over 1. Up 1 because it's positive, and then over, always to the right, 1. Up 1 because it's positive, always to the right, 1. Because our number is 1. And we do that all the way across the graph. Once we reach the edge, we're going to continue going the opposite direction, so that way our points extend to both edges. We can connect our dots. And we have our first line. Now for our second line, again, we're going to pull out our mx value. M and x are always together, so that would be the negative 3 over 2. And our b value, the plus b value at the end, is a minus 7. So we're going to start by plotting the b value first, the minus 7. So put your pencil at 0 and go down to negative 7. And then we're going to use our m value, the negative 3 over 2. Because it's negative, it means we go down. So we go down 3, and then always to the right. Right 2, because that's our other number. 3 and 2. Now we've reached the edge, so we want to go back the other direction, so we go to both edges. So we're going to go up 3 and over 2, following that pattern that allows us to connect our dots in a straight line. Make sure you can continue going all the way to the edge. And we want to look and see where the points cross. Our lines cross at this point here, which is at 1, 2, 3, 4. It's at negative 4 and then negative 1. Negative 4, negative 1 is our final answer because that is where our two lines intersect. For number 2, remember we are referencing our general equation y equals mx plus b. So for our first problem, we're going to pull out our m value, the 1/6, and our b value, the plus 5. We start by graphing the b value first. So putting your pencil at 0, go up to positive 5 and put a point. We're then going to graph the 1/6. It's positive, so positive tells us to go up. So we go up 1, and then the other number is a 6. Always go to the right. So go right 6, and put your point. Now, even though I'm not at the edge, I can't go any further because I'll go off the graph. So we're going to continue going the opposite direction. I go down 1 and over 6, which allows me to connect my dots in a straight line. Once you finish the first equation, you can go ahead and graph the second equation. Again, start by pulling out the m value, the negative 3 over 2, and the b value, negative 5. So we're going to start at the negative 5. Starting at 0, go down to negative 5 and put a point. We use our negative 3 over 2 in order to graph that. We go down because it's negative, so down 3 and right 2. Always go to the right-hand side first. Even though I'm not to the edge, I'm going to stop there because I'm going to go off the graph if I do it again. And so then we can go the other direction, up 3 and over 2, following in that same pattern, allowing us to connect our dots. Continue graphing all the way to the edge. And then look and see. Our lines intersect here, meaning that's going to be our final answer. Our answer is at negative 1, 2, 3, 4, 5, 6. So negative 6. And then positive 1, 2, 3, 4. Negative 6, 4 is our final answer. For number 3, again, always remember we're referencing our general equation, y equals mx plus b. We start by pulling out the m value, which is the 2x. There is no plus b value, no extra numbers at the end, so that means our b value is 0. So we start by graphing the b value 0 first, so put a point there at 0. For our m value, m is a positive 2, so that tells us to go up. Up is positive, so up 2. And then we don't have any other numbers, so we're just going to go over to the right 1. Up 2, because that's what we have, positive 2, and over 1. Up 2, right 1. And we continue that pattern all the way to the edge. Once we reach the edge, we're going to go the opposite direction so that we can continue our line across both sections of the graph. We go down 2 and over 1. Again, following that same pattern and connecting our dots in a straight line. When it comes to the second equation, again, pull out the m value, the 2x, and the b value, the minus 3. Graph the b value first, so graph the negative 3, starting at 0, go to negative 3, and put a point. For our slope, our m value is a positive 2, so we're going to go up 2 and to the right 1. And continuing that pattern of up 2, because it's positive, and right 1, all the way to the edge of the graph, connecting our dots along the way. Once you reach the edge or close to the edge without going over, you can then go the opposite direction. So we go down 2 and over 1, still connecting our dots all the way to the edge. We notice that our lines are parallel, meaning they do not intersect at any point. This is representative of a no solution. There is no intersecting point, so there is no answer, no solution. In number 4, don't forget we're referencing our general equation in slope-intercept form, y equals mx plus b. So we can go ahead and pull out our m value, that's the negative 1/2 x, and the b value, which is the positive 3. Now we can go ahead and graph the positive 3 by starting at 0, go up to positive 3 and put a point. We can then graph the slope, the negative 1/2. Negative tells us to go down, so we go down 1 and then to the right 2 to make the fraction 1/2. Down 1 because it's negative, right 2. We follow that pattern of down 1, right 2 all the way to the edge, connecting our dots along the way. Once we reach the edge, we can then work backwards and go the opposite direction, up 1 and over 2. Continue that pattern until you reach both edges, and we have our first line. Now for our second equation, we have x plus 2y equals 6. That equation is not in slope-intercept form. The y value needs to be by itself, the mx needs to be in the middle, and the plus b needs to be at the end. So we're going to rewrite this equation. We're going to take our 1x and we're going to move it to the middle, because the mx value goes in the middle. So when we move 1x, we do the opposite and it becomes a minus 1x. We have our 2y, we have our minus 1x, and we have our positive 6. Now the y needs to be completely by itself. The equation is y equals mx plus b, not 2y equals. So in order to get rid of the 2, we're going to divide. Now, we cannot do negative 1 divided by 2, not evenly. So we leave it as a fraction, negative 1 divided by 2. We can do 6 divided by 2, and 6 divided by 2 is 3. Once your equation is in slope-intercept form, then you can pull out your rate of change, which is the negative 1/2 x, and your initial value, which is 3. If you notice, our initial values and our rates of changes are the same for both equations. They're both negative 1/2 and they're both positive 3. So if we were to graph it again, we would end up with the same points because it follows the same pattern. If we have a problem that has the same values, the same pattern, that is an infinite solution. For our next problem, remember we're always using our slope-intercept form equation, y equals mx plus b. Start by pulling out the m value, negative 2, and our b value, the minus 7. We start by graphing the b value first, so starting at 0, go down to negative 7, and put your point. To graph our slope of negative 2, negative means down, so we're going to go down 2, and then we always go to the right, and since it's not a fraction, we can just go over 1. I can't go any farther without going off the graph, so I'm going to stop there. But I am going to continue going the opposite direction so that we can continue our line across both sections of the graph. So we're now going to go up 2 and over 1 to complete our line. Following that pattern of up 2 and over 1, connecting our dots along the way so that it makes a straight line across the entire graph. Go until you reach the edge or until you can't go any further, and then you can stop. Now for our second equation, 2x plus y equals negative 7, that equation is not in slope-intercept form. The y value needs to be first, the mx goes in the middle, and the plus b goes at the end. So we're going to start by moving our 2x because the mx needs to go in the middle. So instead of 2x, we do the opposite. We do a minus 2x. And we have an equation that reads y equals the minus 2x and the minus 7. Now that the y is by itself, the mx is in the middle, and the plus b value is at the end, we can go ahead and graph it. Pulling out the rate of change, that would be the negative 2, the mx piece, and the initial value, the minus 7. I noticed that they're the same as my first equation, meaning if we were to graph the problem, we would end up with the same points. It would start at the negative 7, we would go down 2 and over 1, and then work backwards. Because all of our values match up and our lines match up, that is an infinite solution. For our next problem, remember we're referencing our equation y equals mx plus b. We start by pulling out the mx value. As you notice, there's no x value in the equation y equals 5. So if there's no x value, there's no m value, meaning it's just 0. Our b value, the plus b value, would be the positive 5. So when we graph our equation, we graph the positive 5 first. So start at 0, go up to positive 5 and put a point. To graph our slope, we can only go 0, meaning we can't go up, we can't go down, so our line goes straight across. We do the same thing for the second equation, y equals negative 3. Again, there's no x value, so there's no m value. Our answer is just 0. Our initial value, the plus b value, is the negative 3, which we graph first. So starting at 0, go down to negative 3 and put a point. And because our slope is 0, we cannot go up, we cannot go down, so our line goes straight across. And because we have two lines that are parallel, meaning they do not cross, they do not intersect, it means we have a no solution. For number 7, use your slope-intercept form equation, y equals mx plus b, to help you draw out your rate of change. The first one is 2, mx is 2x, and our plus b value at the end is the negative 8. So we start by graphing the b value. So starting at 0, go down to -8 and put a point. Our slope is a +2. Positive is going to go up. So we're going to go up 2 and then just over 1. Up 2, over 1. We follow that pattern, connecting our dots along the way so that they make a straight line. We want our straight line to reach both edges of the graph. So we continue plotting those points, following the pattern up 2, over 1 until we reach the edge. Once you reach the edge, you can then go the opposite direction, down 2 and over 1, so that way our line reaches both edges. For our second equation, we know that this is a -1x, because anytime there's no number, it's just a 1. And then our b value is the -2 at the end. We start by graphing the -2. So starting at 0, go to -2 on your graph and put a point. Our rate of change is -1, so we're going to go down 1, down is negative, down 1, and right, always to the right, 1. We follow that pattern of down 1 and right 1 until we reach the edge of the graph, connecting our dots along the way. Once you reach the edge, go the other direction so that it reaches both sides. We go up 1 and over 1 to follow our straight line. And once we reach both edges, you can look and see where they intersect. Our graph intersects here at this point. That would be at 1, 2, so that's a 2. And then we go down 1, 2, 3, 4. 2 and -4 is our answer of where the lines intersect, where they cross. For number 8, remember we're going to reference our general equation, y equals mx plus b. We're going to pull out the m value, which is an understood 1, because there's no number in front of the x, so it's a 1x. And our plus b value at the end is 4. When we graph it, we start at 0, we go up to +4 and put your point. We then have a slope of +1, so +1 tells us to go up 1, and then always to the right. Up 1 and over 1, up 1 and right 1, following that pattern over and over again until we reach the edge, and we want to connect our dots in a straight line along the way. Once we reach the edge, we're going to go the opposite direction, so we go down 1 and over 1. Again, following the same pattern, putting our dots in a straight line, and we continue that pattern until both edges are met. For our second equation, we pull out the mx value first, so that's the -1/4, and our b value, which is the -6. Starting at 0, we graph the -6 first, so go down to -6. We're then going to graph our -1/4. Negative is down, so we go down 1, and then always to the right, and we go 4. Down 1 and right 4 until we reach the edge. We can't get all the way to the edge because we'll go off the graph, so we can stop there. But we are then going to go the opposite direction, so that way it crosses both sides. We go up 1 and over 4, connecting our dots along the way in a straight line. Stopping until you reach the edge or until you'll go off the graph. Our lines intersect at this point, which would be at -1, 2, 3, 4, 5, 6, 7, 8, so -8, and -1, 2, 3, 4. -8, -4 is our final answer because that is where our lines intersect. For number 9, we're going to use our slope-intercept form equation, y equals mx plus b, in order to help us draw out the rate of change. That's the m, the -1/2, and then the plus b value at the end is 4. Starting at 0, we go up to +4 and plot our b value first. We then have a -1/2. Negative tells us to go down, so we go down 1 and over 2. always to the right, down 1 and then right 2 to make our fraction 1/2. And we continue that pattern until we reach the edge, connecting our dots along the way. We then continue our pattern going the opposite direction so that our line reaches both graphs. So we're going to go up 1 and over 2, again connecting our dots in a straight line. Until it reaches both edges. Now, when it reaches both edges, we can move on to the next equation. We know that our first problem is a 1x, because if there's no number, it's an understood 1. And then our b value is also 1. So we're going to start at 0, and we graph the positive 1 for our b value first. We then use our m value, which is a positive 1, to go up 1 and right 1. Up 1 and right 1, following that pattern of positive 1, so it's up and then always to the right, until we reach the edge, connecting our dots to make a straight line. We need to continue our line going across the graph, so we do the opposite and go down 1 and over 1, connecting our dots along the way to make a straight line. And once both lines reach both edges, you can then see where they intersect. Our lines cross here, which would be at positive 2, positive 3. 2, 3 is our final answer because that is where our lines cross. For number 10, we're going to make sure that we're referencing our slope-intercept form equation, y equals mx plus b. For our first one, we're going to pull out the rate of change, which is the mx value, and our mx value is 1/4. Our b value is the positive 3 at the end. We graph, starting at 0, we graph the positive 3 first. Our rate of change is a positive 1/4, so positive means up. We go up 1 and right 4. Following that pattern until we reach the edge of the graph, or as close as we can get without going off, connecting our dots along the way to make a straight line. We then go the opposite direction. We go down 1 and over 4 to continue our straight line pattern until we reach both edges. For our second equation, we again pull out the rate of change, 1/4 x. And our b value, the -6. Starting at 0, we graph the -6 first. And then we follow our same pattern of a positive 1/4. So positive is up, up 1, and then over right 4. Keep going until you reach the edge or as close as you can get without going off. And then you can go the opposite direction, down 1 and over 4, continuing to connect your dots in a straight line. You'll notice that our lines are parallel, meaning they do not intersect, meaning we have a no solution. They do not cross, so there is no answer. For number 11, use your equation y equals mx plus b to help you pull out the rate of change. In the first equation, that would be the -2x, and the initial value, the b value, the -4. Starting at 0, we graph the -4 first, and then we use our -2 to go down. Down is negative, so down 2, and then always to the right. We're just going to go to the right 1 because there's no fraction. Down 2, because it's -2, and then right 1. Connecting our dots along the way to make a straight line. Once we reach the edge, we can go the opposite direction by going up 2 and over 1, following that same pattern of connecting our dots in a straight line until we reach both edges. Once we reach both edges, we can move on to the next equation. Our m value is the 1/4 x, and the b value is the +5. Starting at 0, we graph the +5 first. We can then graph the positive 1/4. Positive means we go up, so that would be up 1, and then always to the right, we're going to go 4. We follow that pattern of up 1 and right 4 until we reach the edge of the graph, or as close as we can get without going over. Then you can go the opposite direction. We go down 1 and over 4. Again, continuing that pattern, connecting our dots in a straight line along the way. And we can see that our lines intersect. Our lines intersect at -1, 2, 3, 4, so -4, and then positive 1, 2, 3, 4. -4, positive 4 is our final answer because that is the point at which the lines cross. For number 12, reference your slope-intercept form equation y equals mx plus b to help you pull out the m value. In the first equation, the m value is going to be a -1. We know that if there's no number listed, it's always a 1. And then our b value, the plus b at the end, is a -7. When starting at 0, we graph the -7 first. And then we can graph our slope of -1. Negative is down, so we go down 1 and then always to the right. Down 1 and right 1, following that pattern over and over again until we reach the edge and we connect our dots. Once we reach the edge, we're going to continue that pattern but going the opposite direction of up 1 and over 1. Again, connecting our dots so they make a straight line. And we're going to follow that pattern until we reach the other edge of the graph. Once we reach the edge, we can then go to the other equation. Now, 2x plus 2y equals -14 is not in slope-intercept form. The y value is not in front, the mx is not in the middle, and the plus b is not at the end. So we need to rearrange the problem. We start by moving our 2x piece because the 2x needs to go to the middle. Now, when we move 2x, it becomes the opposite. It becomes a -2x. So rewriting our equation, we still have the 2y, but we now have a -2x and a -14. Our last step is to make y be by itself because the equation is y equals mx plus b, not 2y equals mx plus b. To get rid of the 2, we divide. 2 divided by 2 would give us 1, so that's a -1x. 14 divided by 2 would give us 7. Once you rewrite the equation, then you can pull out your m value, your -1x, and your b value, your -7. You should notice that the problems match. The m values are both -1 and the b values are both -7. So if we were to graph them, our points would start at the same location and they would follow the same pattern. When this happens and our lines match and our values match, we have an infinite solution. For number 13, we're going to start by referencing our slope-intercept form equation, y equals mx plus b. That helps us pull out the rate of change in the first problem, the mx value, -3/2, and the b value, the -4. We start at 0 and we graph the -4 first and put a point. We then graph our -3/2. Negative tells us to go down, so we go down 3 and then to the right, always to the right first, which is 2. We continue that pattern of down 3 and right 2 until we reach the edge, connecting our dots in a straight line. And then we go the opposite direction. We're going to go up 3 and over 2. We go the opposite direction so that we can connect our dots in a straight line that reaches both edges of the graph. Up 3 and over 2. We can't go any further without going off the graph, so we can stop there. For the second equation, our mx value is going to be 1/2 and our b value is going to be the -8. So starting at 0, we graph the -8 first, putting a point there. We have a positive 1/2, so positive means we're going to go up, so up 1, and then right 2, making the fraction 1/2. Up 1, right 2. Up 1, right 2. Following that pattern and connecting our dots along the way until we reach the edge. Once we reach the edge, we then go the opposite direction of down 1 and over 2 until our line reaches both edges. We look and see where our lines intersect. Our lines cross at +2 and then down at 1, 2, 3, 4, 5, 6, 7, -7. Because our lines cross once, we have one answer of 2, -7. For number 14, reference your slope-intercept form equation of y equals mx plus b. Remember, the 1x is written in case there's no number, and so m is our 1 value, and b is our +8. We start by graphing our 8 value. Starting at 0, we go up to +8 and put a point. And then we can graph our +1 slope. +1 tells us to go up, so up 1 and then to the right 1. Up 1 and right 1 until we reach the edge. We connect our dots in a straight line, and then we continue the pattern the opposite direction. We go down 1 and over 1, continuing our points in a straight line because we want both sides of the line to reach both edges of the graph. So continue your pattern of down 1 and over 1, always connecting your dots as you go until you reach both edges. Now the second equation, -2x plus 2y equals 10, is not in slope-intercept form. The y value is not in front, the mx is not in the middle, and the +b is not at the end. So we're going to rewrite it. We're going to take our -2x, we're going to do the opposite, we're going to do a +2x. So rewriting it, we have the 2y, we now have a +2x in the middle, and we still have our +10 at the end. However, we're not done. We need to move the 2 that's in front of the y, because the y needs to be completely by itself. Slope-intercept form is y equals mx plus b, not 2y equals mx plus b. So to get rid of the 2, we divide. 2 divided by 2 would give us 1, so 1x. 10 divided by 2 would give us 5. Pulling out our values, our m value, our rate of change is 1, and our initial value is 5. We start at 0 and we graph the +5 first. We then graph our +1 by going up 1 and then always to the right 1. Up 1, right 1, up 1 and right 1, following that pattern until we reach the edge, and then connect our dots in a straight line. We continue that pattern going the opposite direction, down 1 and over 1, connecting our dots in a straight line along the way until we reach both edges of the graph. Once you reach both edges of the graph, you'll see that the lines do not intersect. They do not cross. They are parallel, which means we have a no solution answer. They do not cross, so there is no answer. For number 15, reference your slope-intercept form equation first, y equals mx plus b. Start by pulling out the -1x, that is your m value for the first equation, and your b value, the +2. We start at 0 and we graph the +2 first. We then use our slope of -1. Negative tells us to go down, so we go down 1 and right 1. Continuing that pattern, down 1 and right 1, all the way across the graph until we reach the edge. We can connect our dots along the way, which should make a straight line. Once we reach the edge, we can then go the opposite direction of up 1 and over 1, again connecting our dots in a straight line, following our pattern, and we continue this until we reach the other edge of the graph. Now for the second equation, we have 3x plus 3y equals 6. This is not in slope-intercept form because the y is not in the front, the mx is not in the middle, and the +b is not at the end. We start by moving our 3x value to the middle, Instead of 3x, we do the opposite. We do a minus 3x. Rewriting what we have positive 3y. We now have the minus 3x, and we still have the positive 6. We're still not finished because the y is not by itself. The equation is y equals mx plus b, not 3y equals mx plus b. So we divide by 3 to get the y completely by itself. Negative 3 divided by 3 is negative 1. 6 divided by 3 is 2. We pull out our values, our m value of negative 1 and our b value of positive 2. You should notice that the values are the same for the first and second equations, meaning if we graphed it, they would both start at the negative 2, and they would share the same points because they follow the same pattern of negative 1. Because all of our values match and our lines match, we have an infinite solution. For number 16, we reference our slope-intercept form equation, y equals mx plus b. We start by pulling out our m value, which is 1/3 in the first equation, and our b value, which is 6. When we graph, we start at 0, and we go up to positive 6 and put a point. We graph our slope of positive 1/3. Positive is up, so up 1, and then always to the right. We go right 3 to make the fraction. Up 1 and right 3. Up 1 and right 3. Getting as close to the edge as possible without going over, and connecting our dots to make a straight line. Once you get as close to the edge as possible, you can then go the opposite direction of down 1 and over 3. Again, connecting your dots to make the straight line, and continuing that pattern until you reach the other edge of the graph. For our second equation, we pull out the m value, which is the negative 5/3, and the b value, which is the minus 6. Starting at 0, we go down to negative 6 and put our point. We graph our negative 5/3 by going down. Down is negative. It goes off the graph slightly, but that is okay. Connecting our dots to make a straight line. We then can go the opposite direction of up 5 and over 3. Again, continuing to connect our dots in a straight line. And we continue that pattern of up 5 and over 3 until we get as close to the edge as possible. We can see that our lines intersect here at point negative 1, 2, 3, 4, 5, 6. So negative 6, and then positive 1, 2, 3, 4. Negative 6, positive 4 is our final answer because our lines intersect at that point. For number 17, start by referencing your slope-intercept form equation, y equals mx plus b. Pulling out the mx value, the negative 3. There is no plus b value at the end, so that would just be 0. Start by putting a point at the 0 first. And then we have a negative 3 for our slope. Negative 3 tells us to go down, so down 3. And then we're going to go to the right 1. Connecting our dots along the way, we follow that pattern of down 3, right 1, until we get as close to the edge as we can. Once we get close to the edge, we can then go the opposite direction of up 3 and over 1. Again, connecting our dots in that same straight line pattern, and continuing until we get close to the edge again. For the second equation, we have the slope negative 3, and we have our initial value of positive 4. We graph the positive 4 first, so starting at 0, go to positive 4 and put a point. We then follow our negative 3 pattern of going down 3 and to the right 1, down 3 and right 1, connecting our dots along the way to make a straight line. We continue that pattern until we get close to the edge without going over. We can then go the opposite direction of up 3 and over 1, which continues putting our points in a straight line, and our line gets close to both edges of the graph. We can see that our lines are parallel, meaning they do not intersect, meaning we have a no solution problem. For number 18, reference your equation in slope-intercept form, y equals mx plus b, to help you pull out the m value, negative 1/6, and the b value, positive 4. Starting at 0, we graph the positive 4 first. We then graph the negative 1/6 by going down. Down is negative, so down 1, and then always to the right, we go right 6. We cannot go any further without going off the graph, so we can stop there. Connecting our dots to make a straight line. We then can go the opposite direction of up 1 and over 6. Again, graphing our points to make a straight line. And again, we can't go any further without going off the graph. For our second equation, we pull out our slope, the mx value 1/3, and the b value 1. Starting at 0, we graph the positive 1 first. We then use our positive 1/3 to go up, because up is positive, up 1, and then to the right 3. Up 1 and right 3, following that pattern, getting as close to the edge as possible, and connecting our dots in a straight line. We then go the opposite direction of down 1 and over 3, continuing our straight line pattern across both sections of the graph. We look and see where our points intersect. They cross at positive 1, 2, 3, 4, 5, 6, so positive 6, and then up 1, 2, 3, so positive 3. 6, 3 is our final answer because that is where our lines cross. For number 19, we're going to reference our slope-intercept form equation, y equals mx plus b. Our m value is the negative 1. Even though there's no number, we know that if no number is written, it's an understood 1. And then we have a negative or a positive 5 for our initial value. We start at 0 and graph the positive 5 first. We then follow our rate of change, which is negative 1. So we go down 1 and right 1, down 1 and right 1, following that pattern of putting our points in a straight line all the way to the edge of the graph. Once we reach the edge of the graph, we can then go the opposite direction of up 1 and over 1, following that same straight line pattern, but doing it the opposite so that our line touches both edges of the graph. Once your line touches both edges of the graph, you can move on to the second equation. Our rate of change is 1/3, and our b value is a positive 1. Starting at 0, we graph the positive 1 first. We then graph our positive 1/3, so positive is up, so up 1, and then always to the right, we go right 3. Up 1 and right 3, getting as close to the edge of the graph as possible without going over. And then we go the opposite direction, down 1 and over 3, which continues our straight line pattern, but across the other section of the graph. Look and see where your lines intersect. Our lines cross here at positive 1, 2, 3, so positive 3, and then positive 2. That is our final answer because that is where our lines cross. For our last problem, we're going to reference our equation in slope-intercept form, y equals mx plus b. We pull out our mx value first, which is a positive 4. There is no plus b value at the end, so we know that that's just going to be 0. We start by putting a point at 0. We have a positive 4, which tells us to go up, so go up 4, and then always to the right, we go right 1. Up 4 and right 1, getting as close to the edge as we can without going over. We then follow that pattern, but in the opposite direction of down 4 and over 1, still connecting our dots in that straight line pattern. Now our second equation is not in slope-intercept form. The mx value is not in the middle, the y is not by itself, the plus b is not at the end. So we need to move our pieces. Instead of a negative 4x, we're going to move it to the middle, and we're going to make it a positive 4x. We do the opposite. So we have y equals, we have the positive 4x, And we don't have to put plus 0 at the end. You can, but you don't have to. Zeros are not important. Pulling out our rate of change is our mx value, so that's the 4x. And our plus b value at the end would have been that plus 0. Notice our rates of changes and our initial values are the same for both equations, meaning when we graph it, they would both start at 0. They would both go up 4 and right 1, following that same pattern to get us the same line. This means that we have an infinite solution.